This is the Smart Buildings Academy podcast with Ethan Morris, episode 524. Welcome to the Smart Buildings Academy podcast, everybody. In today's episode, we'll be learning how to commission like a pro, and we'll also provide some field-tested strategies for reliable BAS startups as well. The objectives for today's episode are to understand what commissioning really is. We'll then learn a repeatable BAS startup workflow. We'll then explore a few common pitfalls that you may encounter when performing commissioning. We'll then review some troubleshooting tactics that you can use in case you run into problems. We'll then walk through a couple of real-world examples. And then at the very end, we'll look at actionable strategies to help ensure reliable startups when we're doing the commissioning process. Let's get started. So let's start off today's episode by understanding what commissioning is. Commissioning, simply put, is the structured QA process of our BAS system. And what this does is allows us to verify all the components of the BAS system, make sure that they're operating how they're supposed to. What it does is it verifies the actual performance compared to the design intent from the engineer or the sequence of operations. This commonly includes documentation and testing as well. And the big important thing to remember here, guys, is that commissioning is not just simply turning things on and off, okay? Remember, we're checking devices, we're checking points, we're checking logic, all these things. We're checking everything with our system when we do the commissioning, okay? So now that we know what commissioning is, let's talk about why it matters. The biggest thing here is that it prevents costly rework. So again, we commission these things to ensure that they're operating how they're supposed to. We make sure that all of our devices are physically okay, so nothing's damaged. We have all of our wiring in place and it's not damaged either. But when we go through and we check all these things, it just helps us from going back and finding these issues at a later time. So we're finding them as we go through this process. And again, we're checking everything here. So again, it just helps us prevent doing rework, okay? Next thing here is that it identifies installation errors early on, And again, this ties in with what I just said there in the last point. The first thing we're going to do is physically verify that our sensors are installed correctly, they're wired up, and we're also going to check and make sure that nothing's been damaged. You know, if we're on a site, a project that's under construction still, you know, you can install devices and sensors all over the place. Sometimes they get damaged, sometimes they get the wire can get cut, you know, between your controller and the device. But we're verifying that there's no installation errors when we go through this as well. Next thing is that it can help us by reducing callbacks. So we get less callbacks from the customer because we're verifying all this right from the start. And we should know by the end of our commissioning that everything's operating how it's supposed to per the sequence of operations. Next thing here is that it improves comfort and our energy usage. So this is going to make any type of building manager or building owner happy person, because the people that are working in their building are going to be more comfortable, and it's going to cut down on the energy usage overall of the building as well. And when we cut energy usage, we're going to save some money. So that makes everybody a little bit happier. And then the last thing I have here for this one is that it builds operator and system trust. So again, we're testing everything. We're verifying everything's operational. And when we do this, we can hand off this documentation to our building owners or building management. And we can tell them, hey, we've verified everything. Everything's working how it's supposed to. You know, you should be good to go from here. But this is the big draw as to why commissioning matters and why it's so important to do it correctly. So now let's talk about the BAS startup roadmap. So for number one here, we're going to talk about the pre-startup review. When we do our pre-startup review, we need to check all the documentation and make sure we have all of our materials ready. So tools, documentation, drawings, all these things. Make sure we have all this stuff ready and available so that when we go to start, we have this stuff. We're not wasting time trying to find it. Next thing, number two here, is field verification. This is going to be physical device verification of every device on your system. This is also going to go along with checking wiring, making sure we don't have any wiring nicks or wiring cuts anywhere. It's also going to be checking communication between your controllers, checking power on all this stuff, guys. Is it commissioning and this functional testing portion? It involves everything in your system. So once we've done our field verification, the next thing we can do is our point-to-point checkout. This is going to be the verification of our software points and the logic or any programming that we might have already built out. But we're basically going to go through and we're going to override outputs on and off, make sure that they operate correctly. And then we'll go and we'll test sensors, temperature sensors, humidity sensors, CO2 sensors, things like that, to make sure that they have a proper reading and that they are set up for the actual unit of measurement that that device is going to use. So if it's a CO2 sensor, obviously we're going to need that to read in parts per million. And then if it's a humidity sensor, we're going to need that to be set up as percent relative humidity. So when we do our point-to-point checkout, we're verifying our points are set up correctly in the software, and we're checking our logic as well. Moving on to number 4, now we're moving into our functional testing. This is where we're going to test both our physical and our software side. So this kind of goes into our point-to-point checkout. You can kind of do both of these kind of simultaneously, but we go to our testing both our physical and our software sides, and this is where we're going to start testing logic as well. We'll start testing, make sure that our programming is working how it's supposed to, making sure that our points are operating with that logic how it's supposed to as well. And then once we've completed our point-to-point and functional testing, last thing we can do is any optimizations we might need. So this would be tuning PID loops, calibrating sensors if you have some sensors that are not reading correctly. But we're going to go through and optimize all operations of our system after we've done these 4 checkouts here. And with that, guys, that's our BAS startup roadmap, our 5 points for that one. So now we're going to go a little bit deeper into each one of those points. And the first one here, we're going to start up again with that pre-startup review. So when we start doing this, we're going to need to start off by reviewing the design documents and the sequences of operation. Make sure you get really, really familiar with these, okay? And again, if you have multiple pieces of equipment in your building, you may have a couple different sequences for these pieces of equipment, but read through them, get familiar with them. So once you've reviewed the design documents and the sequences, next thing you can do is verify the submittals and the riser diagrams, or the network topology diagrams you may have, your network maps. We need to verify all this stuff so that we can know what we're working on, okay? We have to know what's in our building and what's in our system so that when we go through and start doing our verifications, we can ensure we have the proper device in the right place and it's wired up correctly. So once we've verified our submittals and our network diagrams, the next thing we can do is check our network architecture. Make sure that our communication bus is laid out how the drawing shows it to be. And then we also use this because we can know where to find our devices. It's typically going to have something in there saying, this one's in room 137, something like that, just an example. But typically when you find this network architecture map, you can use that to know where devices are going to be located within the building as well. So once we've checked that network architecture and everything's where it's supposed to be, next thing we can do is prepare our commissioning forms. And again, guys, I know I beat this one like a dead horse, but document everything. Make sure you're documenting every step you take, any issues you find, anything you come across, make sure you document it, because you can always use that as a resource to go back and find things out if you have to go back to the site. So make sure you're preparing those commissioning forms, and use standardized forms too, guys. Make sure they're the same for every piece of equipment. Obviously the equipment can change, but use standardized forms so that you get used to using the same form over and over again. And your team, same thing. If they get used to seeing the same document, it'll make it easier for them to fill out. So that's preparing those commissioning forms. And with that one, that is our pre-startup review. So now let's talk about an example of our pre-startup done right, okay? So our equipment here is going to be an air handler with a heating coil and an economizer. First thing we'll do is we'll identify our safeties. So it'll be things like free stat, like a low limit thermostat, or a high discharge static sensor, static transducer. Next thing I'll do is I'll run through and I'll document all the damper positions, whether they're opened and closed, or if they're 25%, 50%, depending on the type of actuator it might be. And then with this air handler, the next thing I'm going to do is go through and confirm all of the sensor types match what I'm supposed to have. And again, I'll find that based off of the documentation given to us from the engineers. But we need to make sure we need to make sure that we have all of our sensors installed where they're supposed to be, and make sure that they're on the right piece of equipment that they're supposed to be as well. And if we do all that, that right there would be a pre-startup done correctly, okay? All right, next up for number 2, we've got field verification. Again, this one's going to be where we check the actual physical installation, so the device installation itself. We're checking for damage to the device itself, damage to the wire, and then we're also verifying that the device is wired up and it is wired correctly. So once we check all the device installations, the next thing we can do is check for sensor orientation. We make sure we have proper physical installation on all of these devices as well. And you may have to check manufacturer requirements. They may have a specific standard for how to mount some of these devices as well. So make sure when you guys are installing these devices, or if your subcontractors are installing these devices, make sure to tell them to pull the data sheets out of the box for these devices and give it to you, or hold on to it so that you guys have access to that whenever you're going through and doing these verifications. So check your sensor orientation. Then we need to check our actuator travel. So we're checking actuators. These could be damper or valve actuators. But what we're checking here is to make sure that the damper has full range of motion. So complete easy operation from 0 all the way to 100%. And we need to make sure that that damper is not binding anywhere, or if the valve is really, really hard to turn, the actuator may not be able to open it. So we need to make sure that the valve has full range of motion, and that we make sure that the actuator is able to drive the valve to its full closed and full open positions. Once we have verified all of our actuators, next thing we can do is check our wiring and our labeling. I know I've talked about it in a few of my podcasts before, but I love labeling. Labeling saves so much time and headache. Label everything if you guys can and have the time. But when we check our wiring and labeling, we just need to verify that all of our wiring is labeled at the device and at the controller, both sides. So on the device wire and at the controller wire, make sure that the wiring is done correctly, and make sure that you label both ends of that when you get done with it. And once you've done that, you will have completed your field verification. Now, we talk about a couple of problems when we may find when we come into our field verification. First thing here may be mixed up sensors. This one, not really hard to explain. You could just have a wrong sensor in the wrong place. If that's the case, swap them out with the right one, get everything situated where it's supposed to be. Next one is going to be a variable frequency drive being miswired. This one's a really, really common one, guys. I saw this one all the time in the field, but I would end up having subs that would wire the VFD enable point up to like the fault contacts of the VFD, because in the VFD you'll have a few terminal blocks in there. You may have one that's got 3 like fault relays, and then you'll have a couple in there for start stop operation or enable disable. But I had a few subs wire up the enable on the fault contact. Obviously that's not going to work because the fault contact on a VFD is an output, so that wouldn't work that way. But just be aware that VFDs can get a little bit confusing sometimes on the control wiring side. So just make sure that you're checking those VFDs and their wiring as well to make sure that they're right before you start enabling or overriding points on and off. So that's for VFD wire mismatches. Next one is CO2 sensors being in the wrong location. This one you'll need to go to your mechanical drawings, and then you can verify the proper device location for that one and move it wherever it needs to go. And that is our field verification problems. Next up, we'll talk about the point-to-point checkout. So when we do our point-to-point checkout, this is where we're going to confirm the physical point to the actual database point. We're going to verify that both of them match, their values are the same, and they're both set up the exact same way that, across physical and software side, excuse me. Next thing we'll do is we will test our AI accuracy. If we're using any kind of AI for programming or anything like that, just need to make sure that it's got the proper operation, that it's set up correctly. Next one, this one's huge, guys. Verify your analog output scaling, okay? So if we have analog outputs, we need to make sure that we're setting those up or configuring them per what signal they're supposed to be operating on. Now, that could be 0 to 10 volt DC, could be 4 to 20 milliamp, could be 2 to 10 volt DC. Just depends on the device itself. But you need to verify this in your software. Go to the actuator or whatever it might be, whatever analog output device you have, and verify the signal that it takes to drive that device. And again, this could be 0 to 10 volt, 4 to 20 milliamp, 2 to 10 volt, anything like that. But when you get into the software, open the properties for that device and ensure that the scaling is set correctly for that specific device. Then, once we've verified our analog outputs, next thing we can do is test the binary output operation or digital output operation. Only thing you're going to do here is just verify that the contact closes with the output command from the software. Once you do that, you will have completed your point-to-point checkout. A couple of point-to-point examples here. We've got first one here is to ensure that your sensor accuracy would be plus or minus 2 degrees Fahrenheit. This is just meaning make sure that your sensors are calibrated how they're supposed to. Typically, when you get them from the factory, they're already going to be calibrated, but you may have one or two every once in a while that may come uncalibrated from the factory. The next one here is to ensure that again, your scaling is right. So if it's 0 to 10 volt damper, that's going to be a 0 to 100% operation range. And then if we had like 5 volt, if we were sending 5 volt to that actuator, for instance, that would mean our damper would be 50% open. So 5 volts, 50%, 10 volts would be 100%. Checking those, again, that's our point-to-point example for that, checking that in the software, making sure that that's operating how it's supposed to. Then the last example I have here for a point-to-point checkout, this one is for binary or output, but we ensure that the fan command, when we override that, it's energizing the relay coil, and then we can also use a multimeter to verify that contact closure at our relay or whatever it may be that we're testing. And those are our point-to-point examples. Next is functional testing. And again, this one's going to be where we're testing our devices. So this one's going to be simulating safeties. We're going to check our free stats, the high static alarm, if we have any of those. We're going to check all those, make sure that those safeties are working how they're supposed to. Next one is going to be to confirm alarms. So ensure that our alarms are generating correctly based on the parameters that we've set. And then obviously if they're not generating alarms or the triggers are not set up right, we'll have to go back and fix those. Next thing is to check equipment operation with our software commands. So again, talking about functional testing here, guys. So we're going to check our equipment operation with our software commands. Again, we're going to override these points on and off, or modulate them if it's an analog output to verify operation of the device. So this one here would be an example for this is if we have high discharge air temperature on an air handler, the chill water valve should open to lower the discharge air temperature back down. So what you do here is we can simulate a high discharge air temperature, and then if you should have some programming logic built to open that chill water valve whenever the discharge air gets too high. And that is our functional testing. Next up is an example functional test on an air handler. So this one here, we've got, if you have a low discharge air temperature, our heating valve should open from that one. That's one example. Second example would be if we have high CO2 in our space or in our building, we should get an exhaust damper to open, and then our exhaust fan should start. And this is an air handler again, so the air handler should have an exhaust damper and an exhaust fan on it, just for this example here. And then the last example I have on functional test is go trip the smoke detector, and then make sure that your fan shuts down on emergency and your dampers all close. And that should work with your smoke alarm. And then, like I said, check your fan shut down, make sure your fan shuts off, and then your dampers are closing. But those are a few examples that you can try for your air handler functional testing. And that is our functional testing section there. So next up, we'll discuss optimization and tuning. First thing here is to tune your PID loops. Okay, if your PID loops are not tuned correctly, you're not going to have a really great operation of your devices or your building in general if you're running a lot of PID loops. But you need to make sure that these PID loops are tuned properly and make sure that they're running optimally. Okay. After you've done that, next thing you can do is adjust these set points. Set these to expected like occupant value. So 72 in the room, 70 in the room. Typically, most people are comfortable between 70 and 74 degrees. So adjust these set points. Make sure that when you go through the functional testing, if you're setting these set points way high or way low, you want to go back in and verify, make sure that they're set at a reasonable level, so that if you do leave the site and you get done with your testing, you don't want it to be 60 degrees in someone's room when they come in on a Monday morning. So make sure you're readjusting these set points and set them back to their expected occupant values or close to. Next thing is you can tighten alarm triggers or alarm ranges. Tighten these tolerances on the alarm triggers to ensure we get proper alarm generation, okay? And we want to do this because if we don't set these tolerances very tight on these alarms, sometimes we can just get alarm after alarm after alarm after alarm, and it gets really, really annoying, especially if there's nothing wrong and it's just, like a couple degrees of temperature swing, and we're getting an out of range temperature alarm. Go back in and set those parameters up for that alarm a little bit tighter, so you're not getting a million alarms a day. And if you have people set up on alarm delivery or text message delivery for their alarm generations, they're not going to be very happy if they're getting 300 emails and text messages a day about a room going above 74 degrees, So just make sure you're tightening those alarm triggers down. And then the next thing here is to set up trends. So we need to monitor this for 24 to 48 hours after we've done all these testings. And the best way to do this is to set up trend logs so that we can monitor these values for a specific time period, which this one should be a day to 2 days typically. But then you can go back and look at those trend logs, and then you can verify that everything's running how it's supposed to per the way you set it up. So once you do that, you should have everything optimized and well-tuned in your system. Let's talk about a couple of common pitfalls you guys might encounter when we're going through all these processes. The first one here is skipping documentation. Now this one is on us as the techs and the personnel doing these tests. So if you skip the documentation, you're probably going to be in a world of hurt somewhere down the line. Like I said, I know it seems tedious and seems like it's just a waste of time, but it really will help you guys out in the long run because you can list all your points, you can list controllers, their IP addresses, their MAC addresses, all these things, and it helps you so much, especially if you have to go back down the road and change a device out or change a controller or something out. Just helps you way quicker to change those things out and get things back up and operational again. So do not skip the documentation. Next thing is just assuming that the installations are correct. You know, you're not going by and physically just checking these things to make sure they are correct. That can come back to bite you a little bit too. But you have to go by and physically verify the device and the controller are installed correctly. After that, rushing test is the next big pitfall that you may come into. And I know that, we have deadlines on jobs, guys, and I know that we get screamed at sometimes to get the job done so we can move on. But if you rush these tests and you don't do them correctly, or you don't take your time and do the work right, you're going to end up doing it again. So take the time, do not rush through the work, do it right the first time, and then you don't have to go back and do it all over again. Last thing I have for common pitfalls is poor trade communication. I can't tell you how many times in the field we would be doing a job and just there was no communication between anyone, any of the trades, and things wouldn't get done. Things would get lost in translation. We'd miss deadlines. It's just a terrible idea not to communicate with the teams on a job site, guys. Keep open lines of communications to your team and your leadership and other trades on the site as well. People need to be talking on these job sites so that you know what's going on at all times. And those are our common pitfalls. So a couple of field tested tips that we can go over here. I'm just going to hit these real quick, but you can test your fail safes first. Go through, test these, make sure that they're operational. Next thing is to label everything. Again, I've talked about this one in several podcasts. Label every wire at both ends, device and controller both. Saves you a bunch of time if you have to go trace some wires somewhere down the line. Next one is take photos. Document, put photos with all these documentations that you might have. Gives you a little another resource to go back and look at, and it gives someone else. This kind of goes in with the building operator, building owner trusting us and their system. They have photos they can go back and see that we actually did the work and verified it. So use photos. It's a good resource too. Next thing is to use digital forms. So use a tablet, use a laptop, use digital documentation forms if you can. Just makes things a little bit easier and more streamlined. And then make sure you're tracking all these issues live. Again, this ties in with documenting everything. Make sure you're tracking your issues. Keep the log of all those issues and any resolutions that you come to for those issues as well. And guys, that's our episode for today. So in summary, we learned that commissioning is just basically a quality assurance process. Next thing is that you guys need to remember to follow this 5-step roadmap when we're doing all these checks. Big thing here to remember, always document everything, guys. Take the time, document it. And then finally here, just remember that reliable startups equal better buildings, okay? Always remember that. And if you take the time to do it all correctly, your building's going to run pretty well. So thank you for listening to the Smart Buildings Academy podcast. We hope you learned from this episode. If you found this episode valuable, please leave us a 5-star review on Apple Podcast or Spotify. If you're watching this on YouTube, please like, comment, and subscribe. As always, this will be available on our website at podcast.smartbuildingsacademy.com/524. Again, that's podcast.smartbuildingsacademy.com/524. This has been Ethan, and I really appreciate your time. Have a great day.